Jeez, okay. Just wait. All right. Hopefully it's recording. Okay. I was waiting forever. We are going to talk about my favorite, which is proving triangles congruent. And this, to me, as a student, is where proofs finally started to make sense. There's some strategy involved and how we're presenting information so we can convince others of our statements. So let's go ahead and look at some of the notes. Okay. All right, so I might have to zoom out just a little bit. Okay, so one of the things that we can do, and I'll probably try and include a little bit of a video blur, but if we have two congruent figures, they are going to be the exact same size and the exact same shape. Essentially, if you think about it, we can use a series of different rigid motions, such as the transformations that we talked about in Unit 1. Translation, I could slide one object onto another and they would match up, or a rotation, or like where I kind of spin one to match up onto another one, or a reflection. Okay, so any of these three rigid transformations will produce a congruent figure, and they are the exact same size, meaning the corresponding sides are the same length and the corresponding angles are the same measurement. They're obviously going to be the same shape. Okay. The other thing that once we know we have congruent figures, in this case triangles, we know that all of the corresponding parts of congruent triangles are congruent. And we'll use that later on when we're trying to do some different proofs. But if I can show that two triangles are the exact same size, the exact same dimensions, then we know all of their corresponding sides are going to be the same. And so why this is important is just understanding how we name different triangles is important. So I have triangle gym and triangle nerd. So these triangles are congruent. The corresponding, whatever's the way I named this, triangle GYM, it has to match up over here. So G and N are corresponding and they would be congruent angles. Y and R are corresponding because they both are in the middle, and M and D are corresponding. So when we think about the angles, there's three angles. So angle G corresponds and is congruent to angle N, and then angle Y is congruent to angle R, and angle M is congruent to angle D. And so this is in particular very important how you name your triangles. If it's called triangle gym, the only way it's going to be congruent is if we call it triangle NRD. If I had tried to call it DRN, those two triangles would not be congruent, particularly unless it just happens to be an equilateral triangle. But if this is 60 degrees, or no, let's use something else. Let's say this is 100 degrees for G, then N would be 100 degrees. If we tried to call it triangle D, then you're trying to say that D has the same position as corresponding with G. So it is particular how you name them. So the sides, I always think about this, okay, the first side, GY, is going to match up with the ones that are the first 2 points there, and R. The last two, YM, is going to match up with RD. And then the outer ones, GM or MG. Doesn't matter if we reverse this. If I said YG, MY, that type of thing does not necessarily matter. Those segments are still going to be the same. I just do this for, right, so GM is corresponding with ND or DN. Doesn't matter on the order of that one. All right, so we know all of these little corresponding parts. We kind of have reviewed that. And then let's talk about how we can show just enough information to show that some triangles are congruent to one another. So if I tell you that I have two triangles and all of their side measurements are exactly the same. So this is side side, side, then that's enough. If all three sides are congruent in measure, then there's no other possible way to make another triangle other than a congruent one. Okay, so the corresponding sides are all going to be congruent. If we have two corresponding sides, and the included angle. So it's the angle in between the two sides. So essentially, if I have one side and then I have an angle and then I have another side, if I were to have these measures and draw it a different way, it still would be enough information that the sides would be congruent. So I have a side, an angle, and then another side. Angle side angle tells me two angles, right? Two corresponding angles and the included side. Okay, so angle side angle would look like an angle. So we're going to have this amount, right? And then another one, and we're going to have that. So we'd have something that looks, I guess I could, so we'd have something where we'd have an angle, I'll make that one there, and a side, and then another angle. Okay, and then the last one, two angles and not an included side. So the other thing that you might see, even though it's always written angle, angle, side, as we're recognizing this, if you have a side and then two angles. So how does this look? Non-included side. Okay, so what does that look like? In a triangle, that would look like an angle, and then a side. Notice how this side, angle, side, angle, the side was in between, and then this one, it was two angles, and then a side that was not in between the two angles. Okay. And then hypotenuse leg, this actually has just come about in the last, I don't know, probably decade or so, maybe two. A hypotenuse leg theorem. So this only works with right triangles. So if it's a right triangle, you already know that you have an angle. And they say that if you have a hypotenuse and one leg, then the triangles are congruent. Hypotenuse and one leg. Well, to me, this is, if we were trying to think about angles, this is angle, side, side, okay? Which does not work in anything other than a right triangle. So when we're looking at this, it's why they call this the hypotenuse leg, because there's no squaring. We can't do angle, side, side. And angle, side, side doesn't work for any other triangles other than a right triangle. So hypotenuse leg is what we are calling it for a right triangle. So let's look at some examples. The biggest thing that I think students have trouble with is how to name some of these. So one of the things that you're going to have to pay attention to when you look at a picture, remember we've talked about the reflexive property. You look in the mirror, you see yourself, you know, an angle that's equal to angle A is equal to angle A, the measurements, or segment, you know, AB is congruent to segment AB. So look for, because they probably will not have it marked for you, a reflexive side. So in this example, we know that this side is congruent to itself. Notice of these two triangles, they have a shared side, and it's the whole, I guess, like base or side of that one triangle. It's not, you know, broken up. So that reflexive property, we can mark that. Now I've got 3 pieces of information marked. If you don't have 3 pieces of information marked, try and look and see if there's something that you can use. Vertical angles, reflexive property, some of those might help you get some other things, but you're going to need 3 pieces of information. Now, when I go to name this and try and decide which of these postulates can I be using, start with the side that doesn't have anything marked, okay? If they all are marked, then you have side, side, side. So this one has this side here. Now, it doesn't matter which way you go, but just pick something. So I'm going to go I'll go clockwise since this is a 1. So the first thing I'm going along, I start with the marked side that's not congruent. and I go through and I see I went across the side that has one hash mark, then I had an angle, then I had two hash marks side. So this looks like a side and an angle and a side. Can you do that? Does it match up on the other one as well? We go across, remember we went one, hash mark one, then the angle, then hash mark two. So hash mark one, then the angle, hash mark two. So these are congruent by side, angle, side. Okay. Again, I only see two pieces of information on this triangle. So I have to decide, can I find something else? Or do I have vertical angles? No. Do I have a reflexive side? Yes, I'm going to mark it reflexive side. Okay, then look, I have this triangle with 1, 2, 3, and 1, 2, 3. So this is a perfect example of side, side, side. Okay, that's usually one of the easier ones, and sometimes to make it a little trickier, they try to use a reflexive side, so it might look like there is not enough information. Like here's an example where it looks like there's not enough information. I only have two angles, but again, I have a reflexive side. So let's look at this one. In this one, notice in the top triangle, we have the angle 1, and then we have the side, and then we have angle 2. If you weren't sure where to start, okay, so let's say I picked this side right here. And so that's where I just went around. If I kept going around clockwise, I'd see nothing. Okay, here's angle 2, then the side, then angle 1. Got to kind of do the same thing over here. Look at 2, then side 1, and then angle 1. So this is angle, side, angle. Again, we're looking at this one. I only see two pieces of information, but lo and behold, I have a reflexive side. I'm actually going to mark this one a little bit differently because notice this has one congruent mark, so we don't want to get it confused and say all of these are congruent. So I'll mark it with 2 hash marks. So now let's look. If I start here and I go around clockwise, I have angle, side, side. Angle, side, side is a bad word. We can't use that one. It doesn't work. Angle, side, side is not on our list. You will never see it on a test, I guess, because they just don't want anyone to laugh and say angle, side, side, but angle, side, side doesn't work. Over here, if I happen to look at this triangle and we went and said, there's a side 1, then an included angle, and then side 2. So up here, this triangle looks like it's trying to use side, angle, side, but this triangle did not use side, angle, side. It used angle, side, side, and so these ones are not congruent. So there's no property that makes them congruent, okay? They both have to match up. All right, again, here's some examples where all of these, we haven't had enough information just given to us. We kind of worked for it a little bit using some of our prior knowledge. I don't see any reflexive sides, but I do see vertical angles. So I'm going to mark those, and notice I'm marking them a little bit differently. So we have, I have angle 1, then angle 2, then the side, right? So angle 1, then angle 2, then the side. So here, let's do this. Angle 1, angle 2, and then the side. So this is angle, angle, side. On our last one, again, no reflexive sides, but I do have vertical angles. So I'm just going to start here, and let's just say I'm going around clockwise. So this is side, and then angle 2, angle 1. Okay. So this was side, angle, angle, which remember that is really just called angle, angle, side. So this one's angle, angle, side. Let's look up here. We start here. We started with the side. So let's continue side, angle 2, angle 1. So this is angle, angle, side. If you had called it side, angle, angle, I'd probably correct you for now, but on a test or quiz, the proper form is angle, angle, side. So just be aware that you're going to kind of familiarize yourself with that. So let's go ahead and we're going to do some practice. So in this practice, you're kind of looking at it, and then we're going to name them. And there's kind of multiple ways that there's 3 possible statements that you could have if they are congruent. So let's look at this first one. So I start with this blank side here, I see that they have 3 pieces of information and 3 pieces of information. So I hopefully have enough. So I went, the blank side started there. I went to angle 2, then angle 1, then a side. So angle 2, then angle 1, then a side. So that was angle, angle, side. Angle, angle, side is this right here. And now let's name these, okay? So when we're naming them, we start with some vertices. So I'm going to start with the angle that is not marked. So that's triangle D, and I'm just going to spell out DOG. So I went not marked, angle 1, angle 2. Not marked, angle 1, angle 2. So I have to do the same thing over here. The one that's not marked corresponds with C, angle 1 was A, and angle 2 was T. Okay, so practice some of these and see how you can come up with these. If you're check your answers, I will have the solution posted, and you can go ahead and look at those. And then that would probably be a good stopping point for today. But you can check back for the rest of this video for tomorrow's work. Okay.